Hey everybody, the purpose of this video is to get you some solutions to the relative position quiz. You got a block of data from 4 down to 8 if you're going diagonally left to right. And the first thing you have to do is basically just either manually or with technology run a 5-number summary. I threw it into Excel and used the quartile commands. We mentioned in class that there's 3 quartiles we talked about, Q1, Q2, Q3, Q2 being the median, Q1 and Q3 being the other 2. Excel and other people define the 0th quartile and the 4th quartile as the min and the max. So technically speaking, this is Q0, Q1, Q2, Q3, and Q4, according to some people. And we talked about why that's according to some people and not according to all people. But regardless of what you call them, the smallest data point in the set is 2. The median of the lower half is 8.5. The median is 17.5, implying that we've got an even number of data points. 25 is the upper quartile. It looks like our max is 34. So there's your 5-number summary. The next bit is to draw a box plot on the axes, so we can do that. I'm going to put it below because now that I'll put it up top. That's fine. So 2's about here, 8.5 is over here, 17.5 is over here, 25 is here, and 34 is up here. There's your box. There's your whiskers. And what's cool about that, I haven't marked any outliers. And there don't appear to be. Assuming I've drawn it roughly to scale, I can kind of fudge the IQR method and stack and realize, nope, nothing on that side. Definitely nothing on that side. So what you essentially have is a pretty uniformly non-skewed data set. If you were to graph this, I bet you would look relatively, arguably bell-shaped. Now, that's not entirely true. I take that back to some degree. It depends on the individual pieces given to you. So if you didn't have the individual data, you could look at that and say, yeah, it's about a bell shape. We do have the individual data, and that's what I asked you to do last, which is to put the dot plot on the graph. So what I want to do real quick is I'm going to add that. You might want to fast forward through this next bit. It's going to be kind of tediously slow. So I'm going to go ahead and do that. I'll cut down on the discussion while we do it. 23, 5, 25. 19, 27, 14. 13, 25, 31. 28, 12, 29. 5, 4, 21. 29, 5, 4. Wait, I get those already? 18, 7, 34. That's what I gotta do. Max. 22, 17, 30. This is 22. Crap, I forgot that one was. 17, 30. 12, 16, 25. 8, 34, 10. Oh, 234s, that's kind of cool. 2 max values. And 2, 8. There's our min, and 8. And there's your box plot. So, looking at it, there's not too much skew. It's definitely less variable here than it is here, but again, not crazy amounts of skew anywhere, so I wouldn't expect too much of a deviant distribution. If I was looking at the normal box plot, of course, you can actually see the distribution now as it lies right here. So I guess the point of adding the dot plot, and FYI, you wouldn't want to do this in Excel. Well, you can. If anybody ever needs Excel to do this, I've written some cheats to get both dot plots and box and whiskers in Excel. It's a total pain in the butt. There are no built-ins for either of those things, but you can finagle certain other kinds of charts to get them. So if anybody ever needs it, just email me. But regardless, the idea is a dot plot gives you an idea of clustering. And if you have a dot plot with the box and whisker, it's just more information. Very rarely or very often you don't though. Very often you just get one or the other. So regardless of whether you get one or the other, you can always superimpose a box plot onto a dot plot. I mean, just by simple inspection of the data points and identifying the 5-number summary. But there you go. Hope that helped you get some answers.